All right, so we're ready to start Module 2 of our Unit 6. And this module that we're going to cover in the next 2 weeks has a lot to do with area and perimeter. Today we're really focused on some area problems, but also using some division strategies. So I wanted to point out a couple things that you might find in the Schoology folders here. When you open your April 8th through 17th folders, while I have all the separate days, I also have 2 sets of posters that might come in handy. The first one is some area and perimeter anchor charts that normally we would hang up in the classroom just to kind of remind you about those 2 formulas. And then this one, this division strategy folder, I do think is going to come in really handy for both you and maybe anyone that might be helping you at home. There's 2 or 3 main strategies that we really kind of look at. And remember, I always let you choose whichever one works best for you. So you might want to come back to this set of posters here. If you want to do the traditional long division, this poster is showing those steps. This one is showing 4 different ones. It's showing the standard or traditional algorithm. This partial quotient we don't do a ton of, but this area model is the other one we're going to be using today, as well as a ratio table. So I just wanted to point out those sets of posters in your Schoology folders. So if you need to come and find those, they are there. So today we're working in our spiral notebook, and you can take notes with me or not. That's fine either way. And I'm going to show you 3 different ways to solve a division problem for an area model. Now, right before break, we actually did some of this. We had a division problem, and we used a ratio table. We used an area model, and I quickly showed some traditional long division. And again, you can choose whichever way you want. So I've got a new page in my notebook, and I've got it titled Area Problems for April 9th. Oh, it's focusing. There we go. So my problem here is that I have an area of a rectangle, and it equals 450. And this side of my rectangle is 3. Well, I need to stop and think, what do I know about area? The area is the distance inside that shape, how much area that shape covers. So normally we say rectangle area length times width, but I don't know the length in this case. So the opposite of multiplication is division, and that's how this turns into a division problem. So we are really solving 450 divided by 3 to figure out the length of the long side of the rectangle. Now, I said we were going to show you 3 different ways. I could use a ratio table. Now, I know the short side is 3. So I know I could count by 3s. 1 group is 3. 2 groups is 6. But I have to get all the way to 450. So I'm not sure if skip counting to 3 is going to be my best strategy here. So let's think about what we remember about ratio tables. If I multiply this by 5, the 1 times 5 is 5, I can multiply the 3 by 5. What is 3 groups of 5? 5, 10, 15. Okay, I'm getting closer, but nowhere close to 450. Let's think about some powers of 10. What do we know about 10? What about instead if I do 1 times 10? Well, that's easy. That's 10. What about 3 times 10? That's not too bad. 30. Okay, we're getting there. 450. Oh, let's think about that 50. How could I get 50 up top? I could do 10 times 5. And if I multiply this by 5, I want to multiply this by 5. 3 groups of 5 I know is 15 with a 0. 150. I am definitely getting closer to that 450 now. Now look at this. 3 times 10 was 30. What about if I do 3 times 100? What do I get? I get 300. I multiply the 3 by 100, I have to multiply the 1 by 100, and I get 100. Great, but how does this show me division? Well, remember, we said we were trying to get to 450. Do you see anything in our ratio table that can get to 450? I do. 300, 450. So if I combine these two and add these two and add these two, I get 150. So guess what the length of our long side is? I think it's 150. So that's a way I can use a ratio table. What about if I want to do an area model? And again, you can copy this in your notebook, or you can kind of just come back to this video if you need some help, or look at those posters I showed you. So in multiplication, we have our area model, and we have the outside, and we try and figure out the inside. Well, I know my 3, and I know this inside equals 450. So let's think about what can we do? How can we break this 450 down? Now the tricky part is I want to try and work with this 3. I can't just pick some random numbers because a 3 may not go into those numbers. But I know 3 times 100 is 300. And I know, maybe I'm going to break this down a little bit more. All right. Maybe I know 3 times 20 is 60. So I could come over here. 360 is 360. Am I to that 450 yet? I'm not there yet. All right. Can I do another 60? Ooh, that gets me to 420. So I can do another 60. There's my 20 up top. How many more to get to 450? 20, 30, 40, 50. Ooh, I need 30 more. So if I want 30 more here, how many 3's fit into 30? 3 times what is 30? Hopefully you're thinking 10. Great, but where is my answer in an area model for division? Well, we know the inside because we know that inside's 450. So my answer is across the top here. I have 100, 20, 120, and 40, 150. Oh, do you see how I got that 150 again? Now, if you're getting help from someone at home, chances are they're going to show you the traditional method. Dad, mom, sister, brother. They may not know that part. In some of the posters, you'll see an R at the end. So for this problem, it's 450 divided by 3. So first I'm going to divide. How many 3's fit into just the 4? Well, I can only fit 1. And then I do 1 times 3 is 3. And lining things up, super important. 4 minus 3 is 1. And I bring down one number at a time. And then I go back to the top. 3 divided into 15. How many 3's fit into 15? 3, 6, 9, 12, 15. 5 of them. So my 5 comes up top. 5 times 3 is 15. I subtract. I bring down my 0. Now this is super important. I brought it down, so I still have to go back to the top. 3 fits into 0. It doesn't. If I have nothing, I can't pull 3 out of that. So I need that 0 because that 0 holds the place. 0 times 3 is 0. Subtract. There's nothing to bring down, so that's where my remainder comes in. Do I have anything left? I don't have anything left. Look at that. I got 150 again. So today you're going to be working on some area challenges in your student book. So on page 224 and 225. Now I've asked you to try number 1 and one more. If it takes you more than 10-15 minutes, stop where you're at. That's okay. I will post the answers in tomorrow's folder so you can check to see how well you did. I do want to kind of help you set up number one a little bit. So they tell you you have a rectangle and the area is 693 square meters. And it tells me that the rectangle is 7 meters wide, and I need to figure out how long it is. So part A says make a sketch. So think about that. You're going to make your rectangle and think, where would the 693 go in my sketch, and where would the 7 go? And then I need to figure out, where is my variable? Where is my unknown? So label your sketch. Then create your equation. Now, if you think about it, gave you a big hint with what we were doing today. We're probably going to have some division. So your equation might look something like our practice problem with some division and an unknown. Then it says here, use an array or a ratio table, or maybe you want to try the traditional way. Now, I know another strategy for some of my friends is to use a piece of notebook paper and to go sideways with it, because that helps them keep their numbers in order and nice in line, and that is totally fine as well. So if you need to use some paper and work at it that way, go for it, because that's a great strategy to try and keep some of our sloppy handwriting in line. So if you want to use the traditional way, go ahead and try that. Again, try number one, and if you have time, try one more on either of these pages. All right, good luck.